Akash, shall we start?
Yes, sir, we can start. Almost everyone joined us. So, yes, we can definitely start with the webinar.
Perfect. First of all, I am again thankful to all of you. My name is Sanjeev Gandhi. I am assisted today by Mr. Satyam, who is my team member, who will be presenting my couple of slides, how we will be presenting together. We hope we are audible.
Yes, sir, you are audible.
Yes, sir, you're audible.
Fine. Coming to geoinformatics, I will take only 3 minutes by watch. Most of you know geoinformatics, but I'm sure some of the new members are also here. Geoinformatics, our tagline is you manufacture, we measure. We are a measurement company. Our organization is involved with all sort of geometry related measurement. Satyam, go next. Like all of you, most of you are present in various cities. Geoinformatics is also present in multiple cities. Our head office is in Ghaziabad. Our legal office is in Delhi for all the legal paperwork. We are located in Pune, Chennai, Bangalore, and Hyderabad. And of course, we also have an office in Jamshedpur. When we say geoinformatics, the word geo we have taken from geometry. You all somehow or the other are linked with geometry. Some of you are linked with, I will say, robo applications. Some of you are linked with the material handling. Some of you are linked with the machine building. Most of you know geometry, or most of you are involved with geometry. Our organization is heavily involved with inspection, reverse engineering, and automation for using laser profilers. This is important slide for us to explain you. We are in the domain of inspection. We are in the domain of reverse engineering. We are in the domain of automation. We are in the domain of quality management system, gear inspection system, third party inspection, etc. etc. Always we keep telling you manufacture, we measure. We are the measurement company. Well, whatever we are doing in our country, we are doing in collaboration with our foreign partners. Today, next 1 hour, we are spending one full hour only and only talking about, a product from LMI Technology. In fact, Peter, my team member Peter from Canada is also present in this webinar, and he will be also assisting us in between answering some of your questions if we can't. Go next. We always proud to show our customers, same like all of us. So we work with the electronic manufacturing industry, EMS, which we call mobile making companies like Samsung, Jamel, Cellcom, Wistron, many, even Lava, etc. On the other hand, FMCG like Hindustan Unilever, Procter and Gamble. On the other side, medical application, Dr. Reddy Lab, Baxter. Next. Aerospace customers, automotive customers, defense customers, all are our customers for some product or the other. Yeah. This is the slide where I want to spend a minute for you. Then, of course, we will be jumping directly into technical. Like today, we have invited more than 100 organizations, and who all are present today, just to introduce you guys each other. Most of you are SPM builders, which we call as a special purpose machine builders. Some of you are sensor integrators. Many of you are machine vision specialists. Some of you are automation solution providers. Many of you are 2D inspection specialists, heavily using vision cameras. Many of you are robo integrators. I see many of you are working with the total automation using robotics. And some of you also I see are from material handling solution providers. So these are set of organizations who are present today. What are the takeaways from this 1 hour session? Just in a short, Just today, we want to upskill all of us, including us, from 2D to 3D. You guys know very well 2D. After this 1 hour, I am very sure we will be also talking a lot on 3D. So upskilling from 2D to 3D, whether it's a vision or whether it's a OCR or whether it's a robotic handling applications or a material handling application. Cameras, which are very common and most of you are familiar with that, can handle some of applications. For example, you can do OCR every day, but how about 3D OCR? Having OCR with the depth can be done with the help of sensors. How about material handling, where not only the volume calculation is done, but also the numbers are counted. Also, complete whether the total number of parts are there or not are calculated, can be done by 3D sensors. So today, after 1 hour, we are going to be on the same page, I guess, where we will be migrating from 2D to 3D. Once again, all my next slides, all our slides are in courtesy to LMI. LMI Technology is a Canadian company. We'll be showing you 5 minutes video immediately after that. And that 5 minutes video introduces you complete LMI solutions as a product line, as a solution provider. And Geo Informatics is one of the partner of LMI Technology. Technology. Satyam, if you can play the video of LMI.
Yeah, sure. Just give me a second. I'll go to the next slide. So we'll be presenting about LMI Technologies, and we're talking about this.
This is the story of LMI Technologies, the global leader in 3D scanning and inspection. LMI is a company of passionate, innovative, and dedicated machine vision professionals whose factory-smart 3D sensors and supporting technologies enable the measurement of shape for inline scanning, measurement, and inspection in a wide range of manufacturing applications. Based out of our headquarters and manufacturing hub in Burnaby, British Columbia, Canada, we have 13 regional offices in 8 different countries and an extensive network of valued partners. We bring more than 40 years of experience in the vision industry, over 100 patents, and 420 employees, with 100% focus on developing the industry's leading smart 3D solutions. Our flagship product is the award-winning GoCater 3D Smart Sensor lineup, which consists of 3 primary technology types: laser triangulation, structured light or fringe projection, and line chromatic confocal imaging. GoCaters are not just sensors. They are complete factory-calibrated inspection systems with the ability to make decisions on device and send that information to downstream equipment or databases. Just one 3D Smart sensor can scan, measure, and output volume measurement, detect defects, detect anomalies, detect irregularity, 3D shape inspection, product detection, edge detection, feature position detection, feature detection, orientation detection, height measurement, plane angle measurement, surface roughness, flatness, segmentation, classification, intensity grade, diameter, area, width, length, radius, character reading, presence, absence, and more. All GoCaters have a usable configurable IP address. Simply type it into a web browser and you can access the device's 160 plus onboard tools, data filters, settings, and everything else you need to quickly get your application running. This no extra cost, built-in functionality makes setup time extremely short. An application that might take days to get running with competing sensors takes only hours with GoCater. LMI offers a wide selection of sensors to fit a wide range of applications. Our GoCater 2600 sensors generate 4,200 points per profile and achieve X resolutions up to 2.5 micrometers for detecting tiny defects in precision manufactured parts. Our 2490 has a 2-meter wide field of view, making it a one-of-a-kind sensor for applications like car body inspection or wide conveyor belt scanning. Our G3 snapshot sensors are relied on for all types of vision
Satyam, your video is not audible.
Degree scan of a
Yes,
cylinder
it is audible now.
Okay.
target. LMI's technical team is exceptional at providing reliable and fast customer support. We even offer live training workshops to get you familiarized with GoCater's onboard tools and user interface. With easy robot integration, a comprehensive SDK for advanced users, sensor inspection rates that reach up to 10 kilohertz for line profiler and up to 16 kilohertz for line confocal sensors, and best-in-class performance on challenging materials, LMI has built GoCaters to be as smart, flexible, and simple to use as possible. These smart sensor benefits introduce 3D inspection into many manufacturing applications, including inline part inspection, parcel dimensioning, food process optimization, robotic pick and place, EV battery inspection, tire sidewall and tread inspection, road and rail inspection, wood scanning and optimization, semiconductor wafer inspection, multi-layered cell phone glass inspection, and more. And now with our Factory Smart AI Solutions service, customers can get a turnkey solution to deploy the added power of deep learning-based image inspection to their production processes. If you would like to learn more about LMI Technologies or how GoCater can be used for your application, feel free to reach out to us through the Contacts tab at lmi3d.com.
Satyam,
Yeah.
This is the
So as we saw, all this was all about the LMI technologies. So we saw LMI through us. We are providing 3D laser profilers or 3D smart sensors. So first, I would like to talk about how these 3D sensors are much better than 2D vision camera or 2D measurement systems. So let us compare. And when we talk about a 2D measurement system or 2D vision systems, so they are not calibrated. They are not pre-calibrated sensors. Like you cannot simply take the camera out and use it for any kind of measurement related application without doing the calibration. So these sensors, 3D sensors, are pre-calibrated sensors and are ready to use right out of the box. So when we do when we are using 2D measurement system broadly implemented, we are either using the PC-based systems where we are using industrial camera and we are using their own software for doing the inspections. And some out of there are some of the smart cameras also out there. So some of the techniques which we use for the inspection measurement is pattern matching, edge detection, blob analysis, and variety of other kind of tools which are developed by the vendors. But 2D vision systems have some issues like the lighting conditions. So when the 2D vision cameras are uses lighting conditions, so even a slightest change in lighting condition can affect the edge detection or the measurement accuracy, as it can be seen in the image. So when the illumination changes, your edge locations also changes depending upon the location. Ambient light effect also affect the edge detection locations. If the lighting is not uniform throughout the field of view, you get some of the ways the shadows are there and some other lighting conditions are also there. So with the help of 3D sensor, since we are using a 3D laser light source, so the complete ambient light condition is bandpassed. So we are not dependent on the ambient light condition. We are using the laser light source as the source to get the images. And when we are using laser patterns, so it delivers a very uniform laser profile. As you can see in the intensity and spectrum here, you can see there are multiple irregularities there, but when passing through a particular filter, we are getting a very smooth profile. So the problem of edge detection gets easily eliminated with the help of the 3D sensors. Going to the next, when we are talking about part movement. So basically, if your part is any height variation is there in the part, so up to a certain level, you are able to easily compensate with the camera. But if the height changes dramatically, in that case also you have to use either a telecentric lens or you have to do the movement of the camera up and down, right? So to overcome this with the help of 3D sensors, this thing is entirely removed. So So 3D sensor being calibrated, it's calibrated throughout the volume. So it having its own measurement volume, or we call it as a measurement range. So as far as the part is underneath the measurement range, which is very large compared to the 2D vision systems. So that doesn't affect, we do not have to move the sensor up and down or anywhere. We can simply put any part anywhere within the sensor measurement volume, and we are able to simply measure it. And the targets on precision, we are having, we can have calibrated targets to easily optimize it. Talking about the stability, so when we are using 2D vision systems, if there is any stability of the component, any disability, so that affects like the vibrations and the temperatures are introduced. So sensor vision cameras do get affected. With 3D sensors, all the components are rigidly mounted in the single spine of the sensor itself. Focal lengths are locked, so no changes will be there in the image and the emitter planes. Temperature compensation and metal creep movements are also up to a certain level inside the 3D systems. So how these 3D sensors are much better than 2D vision cameras? We get rich data acquisitions. We are talking about the point cloud data, which we are getting throughout the laser. We are able to, as a result, we are able to get the shape features, we are able to get the object flatness, we are able to get the volume, we can measure the surface angle. All these things we are able to measure with the 3D sensors. Talking about measurement stability, these 3D sensors are much more stable when we are doing the measurements. It can be because being the focal lengths are limited, as we saw earlier, and the images are also there, the temperature compensation is there, the correcting movements with the help of a scan target at starting, we are able to compensate. And these sensors are much more repeatable compared to 2D vision camera, talking about in measurements, majorly. Since the object location from the sensors are automatically compensated, the objects can move anywhere within the field of view of the sensor will result the same result. Even the sensor part is about, like let's take an example, the part is above a certain height threshold from the conveyor system, like suppose 5 mm or 10 mm. And that at that time we scan a particular height, we are getting 5.5 mm, suppose. And after a certain point, like suppose the conveyor belt has shifted a little bit upon 1 mm or 2 mm, even then the result will remain the same. It will not affect the measurement or the repeatability. With the 3D sensors, we are easily able to give the robot a three-dimensional work, like the X, Y, and Z. So since with the help of 2D vision camera, we are able to give the X, Y, and theta angle, but with the help of 3D sensors, we are able to give the X, Y, Z, the roll, pitch, and yaw, which easily enables any robot to go and do a pick and place application, or easily guide the robot to do any kind of seam tracking application or glue bit guidance application. The data synchronization. So talking about the data synchronization, the 3D machine vision the 3D sensor has the ability to stitch the data points together from multiple scanners. We call that as a buddy mode. Like we have a very large target which we want to scan, like a truck frame, and we can scan using multiple sensor grouped together in a single coordinate system and stitch the complex shapes in a single point cloud data, which we'll be seeing in the further slides. So these were some of the advantages the 3D sensor is having to 2D vision cameras. So why isn't 3D common? So according to 3D value map, we go with this. The 3D components are the cameras, the lenses, the laser, the 3D processing, the calibration. If we are talking about individual things, when we go to 3D cameras, the camera with the 3D processing, they have the lens, laser, and the calibration. But with the sensor which we are providing from the LMI Technologies, the Integrator sensor, these sensors are pre-calibrated. Acquisition only you need to do. PC-based tools are there for post-processing, and these all things are in one package, which is the 3D smart sensor. Pre-calibrated acquisition and measurement, decision and control. These all things which you can see in this yellow box, it can be seen inside this. So talking about more on the 3D technologies. So how we do this 3D scanning and inspection. So the 3D smart sensors, we call them as all-in-one package that can do the 3D scanning, the measurement, and pass and fail decision. All can be done with the sensor. So our smart sensor for inline 100% scanning inspection in broad range of market, from having small field of view to large field of views. These sensor, with the help of these sensor, we can achieve the automation, the optimization of the quality control, delivering directly 4.0, Industry 4.0 equation data to learning system also. So now we are talking about the Gocator. So this is the same. So we are talking about the scanning, the measurement, and the control for the material optimization with a high speed in the during the production process. So what are we doing with the Gocator? As you can see, this is a particular part. The laser line of the laser sensor are falling on it, and with the help of a trigger, we are getting 3D point cloud data from these profiles. There are actually two modes with the 3D sensors. One is the profile mode, in which you can get the 3D profiles, and the second is the generation of the 3D point cloud data, so which you can see it here. We call them 3D height maps. And on these 3D height maps, you can easily able to do the measurements, like you can see here, and you can enter the tolerance values, like what can be tolerance limit, like suppose 7.668 is here. So it is the tolerance limit, it is will pass, and the sensor will communicate directly these pass and fail results to your controller or robo or whatever ejection system you are having. So you can directly, on the basis on that simple trigger, you can simply reject or accept a particular part and give an alarm also. So towards 100% quality control, these are basically, you can say in offline article inspection, they were previously the factories were doing offline article inspection, taking a part, going to a standard room and doing the inspection. So that was taking a lot of time process. Then we got to the random part inspection. We took some random part directly from the conveyor production line, and we do the inspection. Now talking about the 100% part inspection, any part which is coming on a conveyor, you want to inspect it for critical dimensions, any kind of linear dimension you want to measure, the sensors are easily able to do that linear dimension inspection. So I will just play a video why we should you choose the Gocator sensor.
Locators are not just sensors. They are complete factory-calibrated inspection systems with the ability to make decisions on device and send that information to downstream equipment or databases. Just one 3D sensor can scan, measure, and output product volume, defects, anomalies, irregularities, 3D shape data, edge detection, feature position, height, radius, orientation, plane angle, surface roughness, flatness, segmentation, classification, intensity grade, diameter, area, width, length, character routing, presence, absence, and more. All Gocators have a default IP address. Type it into a web browser and access the device's 150 plus onboard tools, data filters, settings, and everything else you need to quickly get your application up and running. This no extra cost built-in functionality makes setup time extremely short. An application that might take days to get running with a competing sensor takes only hours with Gocator. LMI has a wide range of sensors to fit a wide range of applications. Our 2490, for example, has a 6.5 feet wide field of view, making it a one-of-a-kind sensor for applications like car body inspection or wide belt scanning. Our smallest field of view sensors can find tiny defects in electronics, even multiple layers of a camera lens assembly with our G5 technology. With over 40 years of experience building three-dimensional sensors, LMI's technical team is exceptional at providing reliable and fast customer support. We even offer free live training workshops to get you familiarized with our onboard tools and user interface. Sometimes our customers need more resolution or a more complete view of an object for their application. Multiple Gocator sensors can easily be linked together to create a wide scan area or provide a more detailed view of an object. Gocator software makes this easy. Just select the sensor layout you are using, set up an aligning tool, and the software does all the rest of the work so that you can quickly start making metrology-grade measurements. With easy robot integration, a comprehensive SDK for advanced users, sensor inspection rates that reach up to 10 kilohertz, and best-in-class performance on challenging materials, LMI has built Gocators to be as useful and simple to use as possible. If you want to learn more about how Gocator can be used for your application, feel free to reach out to us through the sales rep button at lmi3d.com. Gocator.
So talking about the factory smart story. So till now we saw what are the advantages the Gocator sensor is having, what all the qualities are there, why we should choose the Gocator sensors, what advantages provide over other sensors that are in the market. Now we're talking about what can the sensor can provide it to you. So the sensor, what the factories are needing, they are needing a 3D scanning and inspection. We do all the inspection like directly on the conveyor system. We can do the 100% quality control for any kind of linear dimensional inspection. You can do material optimization, pick and place applications. You can do the automation, providing of the robots. So you can simply connect. All about Factory Smart means you can simply connect it anywhere and talk to any kind of system. Easily scalable. You can easily mold the go-getter sensors, inbuilt tools to any kind of application up to your liking, and it is smart. It can make its decision on its own. So this is the same scanning of the parts, giving you the results. You can see here, and dimensions are being measured. According to that, the alarm is being generated. This is the, you can see, material optimization, scanning of the part, giving the coordinates to a cutter, cutting in an equally divided shape sizes. And the last is the automation, guiding of the robots for this. This is a roof placement kind of application for these kind of applications. So we are having with the go-getter sensors two kind of technologies on which the sensor is working. The first is the laser triangulation technology, in which any part can be moved in a running condition and the sensor is able to scan it completely on the top surface and generate a 3D point cloud data. The second is the structured light technology, where the part comes, stops for a moment, the sensor takes a snap, and we get a 3D point cloud data generated. As you can see, this is how the sensor operates. The parts move underneath the sensor, and the sensor scans it and generates a 3D laser profile. This is how it looks like. You can see this is how the sensor inbuilt looks like. And here, you can see there are two modes, which I was talking at starting. The first is the profile mode, which we call it as a profile, which you can see where the laser falls down, we are getting the profile. And this is the scan data or the height map data after scanning a complete component or surface data. So this is how the sensor 3D laser triangulation works. Next is the snapshot sensor, which works on the structured light technology. It takes a single snap and generates a 3D point cloud data. So you can see it has its own scanning volume in which it scans and generates a 3D point cloud data like this. And on this scan data, if you want to cut a section and see the profile, that also you can see. So this is how it works. There is a structured light model in between and two cameras at the angle to capture the whole area of the top. So the go-getter sensor is more than just a sensor. The sensor acquires the 2D data, that is the intensity image, as well along with the 3D data acquisition. It does the measurement also. It does the control. It has all the controlling feature of the sensor inbuilt inside, and the tools are customizable according to the application. And this is all in a web-based interface. So we are having three categories of sensors. One is a point, one is a line, and one is a snapshot. So this video will explain what all the categories are there and how they are being used.
Presenting GoCater from LMI Technologies. Our GoCater all-in-one 3D smart sensors are trusted worldwide for automated inline inspection and material optimization. As all-in-one solutions, GoCater smart sensors combine 3D scanning, measurement, and control in a single device. Advanced web technologies deliver a powerful user interface to any web browser with no external PCs or controllers required. This makes GoCater easy to integrate into existing inspection systems, therefore minimizing system costs and maximizing product quality and throughput by automatically executing pass-fail controls. All GoCaters are factory pre-calibrated, so users can immediately set up the sensor out of the box and be confident that the measurements are mapped to real-world coordinates. It's simple to point it at an object and instantly from a web browser see a complete profile or 3D point cloud, depending on the GoCater model. We can also easily configure functions such as exposure, triggering logic, and output communication methods directly from the web interface. There are three types of GoCater sensors to fit your quality control inspection needs or your specific application. First, single-point profile sensors can measure 3D thickness, height, and surface roughness by combining single points at very high speeds of up to 32,000 Hz to create a profile. Next, line profile sensors can rapidly create cross-sectional profiles for measuring features of an object surface. And by moving the object under the laser line or through the movement of a sensor, the multiple profiles can be combined into a full 3D shape for surface or volumetric analysis. Finally, Structured light snapshot sensors generate high-density 3D data models of a stationary target using stereo cameras and fringe projection. Additionally, the diverse range of GoCater models within each sensor type are available to meet your desired speed, resolution, and field of view requirements. Setting up GoCater is fast and easy. Use your favorite web browser to access and control GoCater with drag and drop functionality. The best thing is that no programming knowledge is required to get started. GoCater's built-in tools provide a full suite of measurement capabilities to solve a wide range of inspection challenges. Calculate widths, heights, angles, radiuses, and a multitude of combinations to measure exactly what you're looking to inspect. GoCater is more than just a sensor. There's a complete inspection ecosystem inside every GoCater. Need a wider or better view? Easily create dual or multi-sensor networks of up to 24 seamlessly connected GoCaters to increase the field of view and scan coverage without compromising quality. Plus, sensor synchronization is automatic and simple to manage. Customize GoCater with LMI's GoCater Development Kit. Gain complete control to manage and customize measurement tools to meet your application needs. GoCater makes 3D scanning and inspection easy. Start thinking of GoCater today to solve your quality control needs.
So this is how I saw there were three kind of categories and how these 3D sensors, three types of sensors can be used for different application. We'll be moving on to that. These are some of the tools which are there inside the GoCater web interface. These are the full suite. These are some of the tools which can be used in the profile mode, like was the profile category. And then we have the tools which can be used on the 3D point cloud data or surface data. These sensors are easily flexible. We can add these sensors to a robo for multiple applications. As previously told also, we are able to build customized solutions using the GoCater sensors. The different multiple sensor networking. Here I want to take a moment and tell you about it. So basically what happens when you are using a single sensor and you are having a fixed field of view, your resolution is quite good. But when you go for a large field of view, you want the high resolution also. In that case, you have to use multiple sensors. But those sensors coordination with each other in a single coordinate system is quite difficult. So advantages of multiple sensor networking that LMI GoCater sensor is having, that easily calibrated. You can use this sensors multiple categories of views. Like here you can see you can use in a wide view where you want to have a very precise resolution but with a wide range of field of view. With like you want a very precise field of view like a 10 mm sensor with multiple sensors together, like a 100 mm FOV you want, you can multiply it by 10 sensors together to get a large field of view and get the same resolution as a 10 mm FOV sensor. So these sensors can be used for multiple size objects. For the small size objects in electronics industry, we are talking about circuit board inspection, we are talking about electronic component inspection, we are talking about smartphones, tablets, wearables, any kind of consumer electronic products we can be used for scanning and giving the best of results. In medical industry, scanning of the needle tapes, medical devices, stents. For the medium-sized objects like automotive components like headlamps, mirrors, brake pads, welding, seam tracking application basically for the welding. For the rubber and tire industry, we are having special sensors for that. For the rubber and tire industry, basically for the black on black, which is very difficult with the help of division camera. We can overcome that with the help of 3D sensors. So within the rubber and tire industry, we check for the extrusions, the tire building process entirely. In the packaging application, basically is checking the cap sealing, whether the cap is properly sealed or not from the top. Filling, if a container is properly filled or not, basically void filling. And the closing, whether the boxes are completely closed or not from the top. Talking about large size objects. So for large size objects like wooden lumber in packaging and logistics, box sizing, pallet scanning, food sizing on the conveyor, material flow, oven or freezing loading. So all these categories can be with the help of GoCater sensor we are able to overcome. So the sensors have, Goketer is having a smallest FOV of 10 mm to largest FOV of 2 meters with a very high resolution. So this is all. This is about the Goketer software, how the software of the Goketer looks like. It's a simple web interface where you can simply call the IP of the sensor and this complete web interface opens up. And all the 2D and 3D measurement tools are available on this. Like these are 3D measurement tools. And you can simply get the outputs from the Goketer also in the form of Ethernet, from Profinet, Ethernet IP, Modbus TCP, ASCII. If you want on digital outputs are also there in the form of serial outputs. That also it is there. You can easily customize the custom tools also with the help of Visual Studio. By giving us the SDK, you can design your own tools and design your own program. It is easy to use the Goketer development kit to write a program. We are having some examples. Based on that, you can utilize that. Goketer development kit can benefits in building a customized application with the help of your own software and our own sensors. You can develop and build with the help of GTK and debug it and build a measurement tools, and you can upload that into that sensor. So when we are talking about smart standalone sensor and versus the PC, so when we are using sensor only, we can give the trigger, we can get a 3D point coordination, we can do the part segmentation, part orientation, part sectioning, and all this, and we can even accelerate the sensor with the help of a PC or an offline accelerator. We call it GoMax. If we want, if the sensor is having a little bit of delay because of the high speed movement or high data processing, in that case, we can accelerate the sensor to the PC and external things. So integration with the robots, talking about how the Goketer can be integrated with the robot. I'm talking about that.
Quality inspection and enhanced material optimization. Smart manufacturing, industrial Internet of Things, and Industry 4.0 aren't just buzzwords. They're ingrained into our way of thinking and the products we produce. To help place the smart factories of tomorrow in reach today, we are pleased to showcase Goketer as our answer. Goketer is an easy-to-use, flexible design that delivers high-performance machine vision with seamless data communication so your factory can operate more efficiently and profitably. We have two trusted 3D technologies for your smart factory applications: laser profilers and snapshot sensors. Our 3D smart sensors can also report measurement results, monitor trends, or network with other machinery to exchange or combine data.
So talking about the next best thing that the Goketer sensor is having is with the UR Robo. So with the UR Robo, we are having a built-in plugin. With the help of that plugin, you are easily able to do an hand-eye calibration with the UR Robo and the Goketer sensors. And after doing the hand-eye calibration, whenever the sensor scans any part within the field of view of the field of view or on the measurement volume range of the sensor, that coordinates X, Y, Z, roll, pitch, and yaw with the help of a tool called Feature Robot Pose. We are able to send those values directly to the robo, and those coordinates are directly from the robo base. That is from the 0, 0, from where the robo is standing. So we do not have to give any offsets, which we have to do when we are calibrating with a camera or with another sensor brands. So this is the major advantages that the Goketer sensor is having with the help of a UR Robo. I'll just show you a quick video of that, how it is being done, so that you can get a better idea.
And welcome to this brief demo showing how to use an LMI 3D machine vision system for true 3D pick and place with a UR robot. We're going to be scanning an earbud with a Goketer laser line profiler, accurately locating the stem of that part, and then communicating that location to a UR5E robot so we can pick it and put it perfectly inside the earbud case. Right-hand corner, we have our camera view in the upper right-hand corner, our teach pendant in the lower right.
From here, you can see how the GoGetter is mounted on a robo, UR robo, and we are doing the calling the subroutine on the UR touchpad.
Our GoGetter laser line profile. Before we do any pick and place on a flat plane, and we're going to run a calibration routine that generates a transformation matrix, which tells.
So basically what we are doing here, we are using a ball bar. We are going to scan that ball bar with the help of a 3D laser sensor. And when the ball bar is scanned, all the values will be transmitted to the robo here.
UR robot where the GoGetter is. So that when I send coordinates from my 3D system to the robot, they're going to be meaningful. And the robot is going to be able to move to that point and take our part.
So here we have simply loaded a job file which comes with the plugin with the sensor, and that plugin is job file is containing only a single surface ball bar tool, which will give
a file already created that's going to look for a ball bar. Let's go ahead and run our subroutine. So you'll see the laser line profiler scan 8 times and find the ball bar in each of those scans. And I'm going to generate our transformation matrix.
So what the robo is doing, according to a plugin, it takes 5 to 6 scans with the help of the sensor in different orientations, so that we are able to get the XYZ coordinate with the different views also.
Satyam, a bit fast, we need to move.
Yeah, sure. I'll just accelerate this video. So now that the calibration has been done.
Subroutine on the UR robot side.
Yeah, and here you can see from here. And after doing all the programming on this side for giving the XYZ role pitch and yaw.
Is where the robot on the robot side, we just receive that information.
Here you can see
and
all the values from directly from the 00. And whenever now the sensor scans, the robot can go pick the part and place it. So this is the major advantage that the GoGetter sensor and the UR Robo plugin is having. Talking about further case studies and moving on to further examples. So applications where the sensor can be used in electronics industry, in automotive industry, during automation, in transportation, rubber and tire, wood, and other customized application depending upon the application. So these are some of the existing customers for the laser sensors and the structure light. Talking about the electronics industry, so here we have an application where we are doing the connector pins, scanning the connector pins for this XY location, detecting its presence, and with an accuracy of 0.1 mm. So what we are getting an output of 2D image and a 3D data at the same time. And the sensor used in this system is a GoGetter 2330 with a plugin of the LabVIEW system. So GoGetter is also having a plugin developed for the LabVIEW system, in which you can directly send the data to the LabVIEW with the help of the plugin available. Next application which you can see is the capacitor application. Here we are checking the presence and the height of the capacitor body. We are also verifying the presence of the 4 clips which are present in a T-player housing. We can see the V shape here also, and the V shape should not be less than 0.4 mm. The tolerance here is plus minus 0.5 mm. Sensor uses GoCare 2330, and again we are using the lab view. So here is one application where we are scanning the same connector pins. You can see chip pins inspection. This is how it is being done. The next, we are checking the good planarity of the chip. The chip is a size of 9.9 9 by 9 mm, the dimension of 100 by 100 mm. So we request of plus minus 10 microns. We need to scan the complete part, and here we are using the actual plugin available for the Halcon system and the GoCater sensor to check the clarity. Moving on to next application, SIM card slot height difference we need to check. Here with the accuracy of Z in 10 microns, we are using 2020, again with the Halcon for the complete development of the UI. Here we are doing for the electronic industry for the cell phone housing. Again, very tight tolerance. We are using multiple sensors together. You can see T0, T1, T2, T3, and T4. So we are using multiple sensors to scan in 4 different scans and get the results. These are some of the other applications of the electronic industry. Scanning of the keyboard for the height measurement, cell phone glass inspection, solder balls inspection, other GoCater application for the electronics industry. This is one of the major applications which comes for in a bead application, glue bead, adhesive bead application, where we scan a particular bead and we need to inspect whether the bead is properly made or not. So we are able to give you the correct width, correct height, the continuity, till at what section we need to check, at how much distance from one another throughout the bead we can check. So we are having a special tool called you can say surface track, which does all of this. And last but not least, solder paste inspection. So for the EV batteries also, we are having one special GoCater sensor. And what all the application in the EV batteries you can use the sensor. This video is going to explain that.
Over 6.5 million electric vehicles were sold in 2021. That's 108% more than were sold in 2020. The increase in demand has already permanently changed
So
the
I
car
will
manufacturing
skip
landscape.
that. Let's move on to the further.
Success. EV battery manufacturing can be broken up into 4 general steps: electrode manufacturing, cell packaging, cell to module assembly, and module to pack assembly. GoCater 3D sensors and their built-in onboard tools are used in every stage of this process. Let's look at electrode manufacturing first. During this step, GoCaters are used to ensure uniform shape and thickness of the electrode as the slurry is applied. Sensors are also used to measure the distance between tabs on a cell sheet. Tolerances are extremely small for these applications, so high-resolution, small field of view sensors are used. 2 of the most common cell types used in electric vehicles are cylindrical and prismatic. Cylindrical cells are rigorously tested for any dents or scratches on the cell body. Prismatic batteries are first measured for gap and flush along a weld line. After welding, they are inspected again to ensure that the weld seam is uniform and within tolerances. I spoke with James Ma, our technical service manager in Shanghai, to learn more about this application.
When we put the materials into the battery cell, we need to seal the lid of the battery cell with very fine welding process. That is, make sure that there's no leakage and there's no defects on the welding. Otherwise, there will be risk when we put the cell into the car. The dimension of the welding seam is only like 3 or 5 millimeter wide. So we picked our high resolution, high speed sensor, which is 2520, to do the measurement. For the battery cell, it has a shiny surface. So if you use blue line laser, it has less reflection from these surfaces. So the data quality is better. When we have a new customer, for example, from the EV battery market, we are not only trying to sell them the product we have, we are looking for a long-term partnership. We actually have our engineers go and see what the customer really appreciates this.
Application for module. 4 of them are precisely grouped together, forming a battery module. An example application for module inspection is for sensors to measure the spaces between individual cells. Finally, GoCators are used at the last stage of the process, combining modules into a single battery pack, ready to be installed into a new electric vehicle. EV battery production continues to rapidly grow around the world. LMI is not only
So this is how in the EV battery sector and the application where the GoCator sensor can be used. Now I'll move on to the automotive sector. So for the automotive sector, for the engine cradle inspection, we have used the 32 snapshot sensor in multiple sensors in different views to scan the part, having very fast cycle time. Here you can see this is how the sensor has been positioned. You can see multiple sensors, at least seven sensors are there. 20 plus GoCator sensors are there for this system. Next is the flexible measurement systems. You can see throughout the part which we are doing. Next is the gap and flush inspection with the help of GoCator sensors at different locations mounted on a robo. Again, with the help of a line sensor. And this is how the gap and flush inspection is being done.
Provide our automotive partners with cutting-edge gap and flush measurement capabilities. For the configuration seen here, we are using one downward-facing, ultra-wide field of view GoCator 2490 to determine the 6 degrees of freedom of the vehicle. That information is then relayed to a KUKA robot arm, allowing our buddied Blue Line GoCator 2440s to make detailed gap and flush measurements. Buddied sensors are networked to automatically generate a single, high-accuracy 3D scan of the target. This configuration also solves for any potential occlusions on the scan target. Scanning and inspection happens continuously and with no external computing required, all while the vehicle moves down the assembly line. Our Blue Line laser sensors are specifically designed to measure shiny or specular surfaces. This makes them especially suited for gap and flush measurements. Measuring surfaces like headlights, windows, and glossy white or black paint can be a challenge for traditional red line laser sensors. Red line laser sensors work better on lower reflectivity or matte surfaces, particularly on fast-moving targets. However, for specular or shiny surfaces, the red laser light becomes distorted, resulting in a speckle effect. In contrast, the shorter wavelength of the blue laser sensor produces much less speckling, resulting in lower noise levels, typically by a factor of 2 to 3 compared to red laser sensors. Using 2 networked blue laser sensors allows the client to scan deeper into the gap, generating more complete and precise measurement data. The process of combining and aligning multiple sensors is simple with our built-in alignment procedure. With a combined 3D point cloud dataset, we can now do our gap and flush measurements on the sensor in real time. Depending on the surface quality, our system can capture up to 60 measurement points per minute, taking 0.5 to 1 second per measurement point, including evaluation. These scans are extremely detailed, measuring not only gap distance to the 10th of a millimeter, but also the shape, smoothness, and curvature of the surface. With this data, many measurements, including calculations and pass-fail decisions, are made, allowing for a high level of quality assurance. Every GoCator sensor leaves our factory after undergoing rigorous factory calibration, assuring accurate measurements directly out of the box. Our sensors are
So as you have seen how the GoCator sensors are able to do the gap and flush inspection directly in the inline when the car is in a moving condition, or it can be a BIW in the moving condition while mounted on a robo. Like this application can be done. The robo sensors. Yeah.
Satyam, I would like to stop you for a minute and let our audience know that they can even, post their questions in Q&A section. So we can answer it at the end of this presentation one by one. Thank you. You can continue, Satyam.
Okay. So next is the windshield lining or roof panel insertion. The sensors are guiding the robo to do the very proper fit and reduce the chance of any leaks. This can be done automatically without any, you can say, pre-programming the robo, as each sensor will be giving you what is the location, and especially from hitting the car body. You can see
Satyam, we are not able to hear the audio of this video.
Sorry.
We are not able to hear the audio of this video.
Oh,
Is there any?
there's some. No, it's not. No one speaking. It's just a background noise.
Okay, okay.
So this is how you can see the robots are helping the robot. Sensors are helping the robot for the pick and place applications like this, and aligning these windshields and the roof lining application can be happening. Talking about next applications, like seam tracking application, where sensor is guiding the robot along the particular path. You can see here, since the path is not straight and it is deviated, so either we have to teach the robot all its position for each individual part, or we can simply mount a particular sensor, and the sensor can give you all the coordinates required for the seam tracking application. Like you can see. This is one of the indicators which has done this application. Vertical motion without a sensor feedback, not with the help of sensor feedback. This directly being guided. Horizontal motion without feedback. Now you can see. So this is how our sensors can help for the seam tracking applications, giving all the required feedback to the robot so that the welding can be done. Next is the volume checking application, where this is one of the major things with the GoKeter snapshot sensor is having. With the help of snapshot sensor, we are able to check the volume of an engine block for without the standard methods, which are filling the block with either oil or some other lubricants, so that it doesn't damage it, and check the volume. So with the accuracy of plus minus 0.04 cm3, the sensor simply snaps that image, fills the complete image, and you can get the volume out of it. This is the exclusive tool which the GoKeter sensor is only having. No other sensor is having this tool, with the help of which we can do this application. Going for the next industry, that is rubber and tire industry. So with the rubber and tire industry, there are multiple applications where the sensor can be used, like the thickness of the canted rubber, embossing depth, and the canted rubber, width and thickness of the extruder, groove width, groove depth and of the rubber extruder, tread extrusion profile checking, rubber plate inspection, and bulge dent on the runout of the tire. These are some of the applications where the sensor can be used. Like on this, you can see different grooves and a sheet widths are there. We can easily able to do this application with the sensors. Tire sidewall inspection for the bulge and dent detection, checking the runout, peak to peak, and the harmonics. Here in this video, you can see we are doing the OCR and we are checking the runout also. You can see two sensors are there. One sensor is doing the OCR on the sidewall of the tire. We are using the GoKeter 2430 and the 2440 here. So one laser profile is here and one is here. And the GoKeter 2440. Here you can see the scan data and you can see the OCR which is being done here. This is the OCR. And this is a tread. So in this, we can check the groove width, we can check the groove depth, we can check whether the shape of the groove is properly made or not, whether it is a U-shaped or a V-shape. You can see on the tire, we are doing the scanning, we are doing the OCR also. Same. You can simply do all kind of OCR applications with the help of the GoKeter sensor. It can be alphanumeric code reading or dot code found or dot code OCR. all those things. Talking about the factory automation, where the sensor can be used for the packaging application, can check the cell integrity, whether it is being lifted up or not, whether it is properly flat or not, doing the filling inspection. For the opaque jars or opaque bottles, where the camera from the side cannot judge it. Here you can see some of the major application for like void filling application.
Can measure the length, width, height, and location of multiple packages per second as they move down a conveyor belt. All of the measurements are made on sensor using our browser-based interface. No separate software or programming required. Each of our sensors vary in measurement range and resolution, so it is important to pick the correct one for your application. The GoCater 2490 has a high enough resolution to measure not only the dimensions of a variety of parcel sizes, but even detects subtle defects in the packaging. This inline inspection functionality allows a pass-fail decision to be triggered if a package with a defect is detected. LMI is also involved with a more advanced packaging application called void filling. Void filling involves scanning an open package with items in it and determining how much packaging material is required to fill the empty space. For this application, many sensors, including the 2490, can be used. However, the 2880, with its dual camera configuration, makes it the best choice to avoid occlusion within the box or tote on a single sensor. A series of GoCater software tools are then used to acquire the volume of empty space within the box. GoCater 3D sensors are particularly useful in this application for their ability to scan irregular or high contrast objects in the package. This ability to scan irregular objects is also helpful for imaging the external surface of flexible plastic packages such as polybags, which companies are starting to use more of. LMI sensors can be used at every stage of the shipping process. First, to measure and inspect objects prior to packaging. Second, to inspect objects when they're inside an open package. And third, to inspect and measure the closed package for shipping. If you want to learn more about our sensors and the many applications they can be used for, take a look at our website.
So this is how in the packaging industry, the sensors can be used for all these three applications: before packaging, during the packaging for the void filling, and after the packaging of the boxes for checking out the defects. Like this, you can see in this yogurt cup rim seal inspection, we are scanning the complete side walls, and we are checking the cup. Good flat, this is bad flat. You can see the presence absence, the box volume measurement, the sealing inspection, which are not possible with the 2D vision systems. This is the more in the food industry, potato sorting, where we are checking the volume measurement of a particular potato according to the requirement needs. If it is not, then it is being thrown out. For the metals, checking thickness of the sheets, these kind of applications, pipe diameter, pipe straightness, tooling shapes, steel plate alignment. Even for the transportation, like the road scanning, we are having special sensors, which are infrared sensors for the road scanning application, checking the road roughness, sag and hump, rutting, pavement edges. You can check the road for these things. Texture also, roughness. This is how the sensors are being mounted here. You can see multiple sensors are mounted over here. Using the sensor is 2375, using 7 sensors, full lane across. The scanning of the actual cracks in the pavements on the roads. Even the rails, tram wheel alignment also, this is also being inspected for that. The transportation for the monitors and pantographs, to check those also. The sheet with the non-contact and high speed and high accuracy. Even the railway tracks also, for checking the proper tracks, whether there is any kind of defects are there, what is the angle, what all the things are there. These all things can be done. Full steel rail, width, thickness, waviness, twist, surface damage, all those things. Some of the other applications which are out there, doing the part inspection, height measurements, finding out the irregularities on that. So this was all about the 3D sensors and what we are having with how we can help in multiple industries with the help of the 3D sensors. Now, Akash, I can guess we can start the QA sessions.
Yeah, so Satyam, we have one question from Mr. Gokul. He would like to know, I would like to know the scanning speed when we
Mhm.
mount the scanner on robot flank. In
Okay.
robot configuration, he also want to know, does SDK is enough for making path offset after inspection?
Okay. So, sir, talking about the scanning speed, the sensor, we are having two categories of sensors. One sensor we are having which can run at a high speed of 5,000 profiles per second. Yeah.
Yeah, carry on.
Yeah. So the sensor with we have having two sensors, one with a scanning speed of 5,000 profiles per second, and the second with a scanning speed of 10,000 profiles per second. According to the need and require doing the settings, we can run at a very high speed also. That is not an issue regarding the speed. Talking about the offset, the sensor can give you the all the details, that is the X, Y, Z, with directly from the Go web interface. We can give you the X, Y, Z and roll pitch in your. With it, you can, if you are using a different brand robo other than you are, then also we can give you without SDK all those things. You can give the offset from a particular origin 00. I guess this helps. Going to the next question.
Just a comment for the benefit of everyone. Whatever applications we have shown today are done by various integrators in the world. So Geo Informatics works with many integrators within India, and we supply them such kind of solutions. Now to move next step, probably we can give you demonstration of these go-caters. We have demo pool available in our country with point sensor, line sensor, snapshot sensor. We have couple of them, in the numbers. Probably we can loan some of these sensors to you. Such kind of things are possible so that you can do certain experiments on your machine. It is not necessary that you should have all the sensors with you to start a machine. Probably you can borrow some sensor from us to start with. But the applications shown by Satyam, be it automotive or electronics or packaging or just a 3D profiling or robo application, are practical applications happening within our country, and end users. See, most of us are not end users. We are all B2B. Most of the people like OEMs, be it Maruti and their vendors or Tata vendors, they are looking for such kind of things. One of the application what Satya was showing was volume checking, right? Now, volume checking is a very, very important application for most of the cylinder block and cylinder head builders. So what you guys need is just you need to upskill from 2D to 3D, because 3D is what is now coming on the horizon. Just a observation from my side and maybe a comment from my side.
I don't
Okay.
see any other questions. We
Yeah,
shall
we
wait
don't
for
have any more
questions.
questions. So I think Satyam, we should wait for another 2-3 minutes, and almost we are above the time. So I guess we should wait for 2-3 minutes, and let's see if any other questions are there from attendees.
Sure.
Okay, so we have another question from Mr. Ambika. He is asking how your sensor will support for manufacturing plain machinery conveyors.
I would like to know more about this application, like manufacturing plane machinery conveyors. Are you, sir, talking about the what is the variation in the conveyor belt when it is on the running? I want to check what is the deviation in the plane conveyor belt. Want to check that or something else?
If I'm able to read this, manufacturing plane machinery conveyors. When you are making a conveyors, in fact, we use conveyors for doing automation. If your application is to build the conveyors which are very precise, so that you can monitor all the movements, probably if that is your question, there is very surely application where you can use a line sensor on the top of the conveyor. If conveyor is, I will say, dithering or vibrating left and right, we can check that movement very precisely, if that is the question. Probably conveyor builders are users of such kind of systems, mostly the line sensors. But
So basically,
as Satyam said, we require a little bit more information, which we can do one-to-one, Ambika.
Mr. Ambika also posted SMT line electronic manufacturing. So maybe if this can help.
Okay. So this is SMT line building. I guess let us try to connect one-to-one. This requires a little bit more discussion about the size, about the speed at which conveyor is going to move, etc., etc.
So, Mr. Ambika, I'll be just dropping the mail and our phone number, official phone number, so you can just connect with us, and we can also, answer all your questions, whatever you want to know. That would be great. So, Satyam, I am moving forward with another question. So, we have one more question from Mr. Manoj. He is asking, can we interface these sensor to Omron PLC? I am using Omron NJ-NX system, protocol available, Ethernet, IP, and EtherCAT.
okay. So, Mr. Manoj, we are able to integrate these sensors with any kind of brand PLC. We are having it available. You can say protocols for Ethernet IP, Profinet, Modbus TCP/IP, and ASCII. So yes, with the help of Ethernet IP, we will be definitely able to communicate with the Omron PLC. That will not be a problem. We can provide the EDS file to you, which will be having all the registered informations, so that you can extract the data from those registers. I hope this helps you.
Okay, so I think we are almost done. We don't have any more questions right now. Okay, so we have one more question from Mr. Utkarsh. He is asking about the repeatability and accuracy of line scanner sensor.
Okay, so regarding the repeatability and the accuracy, so it will depend basically from model to model. If you are using a very small field of view of sensor, then you will be having a very high accuracy and repeatability with a high resolution. And if you are using a large field of view sensor, then you will be having a, let's say, different accuracy. So giving an example, like we are having one sensor 2510, which is having a FOV of 10 mm with an accuracy of 6 microns in z-axis and in up to 7 to 8 microns in y-axis. So that is for the small FOV, and we are talking about the large FOV sensors. We are having the largest FOV of 2 meters. A new sensor that is a 2690 give you an accuracy of 0.5 mm in x-axis and up to 300 microns in z-axis when we are talking about up to 50 microns, 2 meters FOV.
It will be always a good idea to share the detailed catalog of individual model. GoCater series have various models based on field of view. So it is always better to communicate on the catalog.
Okay, I think we are almost done. Let's see. Okay, so we have one more question from Mr. Rama. He is asking, can we have your call? Yes, Mr. Rama, you can have our contact number in Delhi. So I'll be just sharing you the mail ID and the contact number. And we have one more question from Mr. Sorry, I'm not able to spell, but Gavan. we have a their question is, we have a requirement to cover area 2400 by 1100 mm. Is it possible to cover this much area in one camera?
Okay. So maximum field of view sensor which we are having is a 2-meter profiler, laser profiler. So that is the maximum which we are having. But we can cover with this with two sensors. With two sensors, we will be able to cover this field of view, 2400. Since length is an open, only the width is the constraint. So if I'm not wrong, that width is going to be 1100 mm. So in that case, with a single sensor, we'll be able to cover it. But if the width is more than 2 meters, then in that case, we need to use two sensors.
Okay, I hope we answered it. So we have another question from Mr. Mandal. He is asking, can you check oil hole drill angle in an automobile piston? Right. He's from, okay. Yeah, this is the question. Can you check oil hole drill angle in an automobile piston?
As of now, we have not done this oil hole drill. We have to scan it with the sensors to check the feasibility for that. So that will be better. First, we have to scan it, then I will be able to give you a proper answer on this. You can contact us and we can do one, you can say, proof of concept for you. We can see what is the possibilities there, so that you will be able to see that.
Okay, Satyam. Mr. Bhupetra Gavan is again asking for the approximate budgetary for that. So you need to contact us, so our sales team can probably guide you further on this. I
Yes,
think
price is also just for everyone. Price is a function of application, which model we have to use, whether point, line. So let us connect after this event, and surely we can give you the proper budgetary offer.
So I think, sir, we are almost done with all the questions. So what I'll be doing, I am just dropping my email ID and the phone number for your request to contact us. Right now we are in Ghaziabad office. We have multiple branch, as sir already told you, in Pan India. So you can contact us from anywhere, not a problem. We can always help you out. So I'm just dropping my mail ID and phone number in chat box. You can note it down and shoot us a mail or contact us directly on the phone number. Thank you everyone for being with us for an hour. So I guess we are done for the webinar. Sir, you want to say something?
We just want to say thanks. In fact, the hour went into 1 hour 22 minutes. Thank you to everyone for attending this webinar, and looking forward to have one-to-one discussion at some point of time.
Okay, thank you everyone. I had also dropped my email ID and the phone number. You can contact us directly for one-to-one discussion, as sir told you. Thank you everyone for attending the webinar.
Thanks everyone.
Thank you, sir.
Thanks, Peter, as well. Thank you so much.